complete idea. It's a war situation and you have to troubleshoot your production issues. So in this top-down approach, there are multitude of problems that one Postgres server can face or any database in general can face. So we are going to take some of the common challenges which comprise of almost 80 to 90% of production issues, and we'll see how to solve that and look at each step in terms of how what exactly is the problem. Then we'll look at how you will analyze that, and then you will identify and we'll share how we have resolved and how one should be resolving that. So if you see that there are 5 or 6 challenges that we are going to take. One is scary plans and statistics out of it, which is common, like stats are not in place and things are not working. Then vacuum process. No Postgres conference is complete without vacuum being talked about. So the third is connections, then multi transactions. This is a special feature in Postgres. Then how memory utilization, log contentions are taken care. And then we'll also have a quick look on other challenges which might be very nuanced and very corner cases. And we'll see if we can show a small, simple demo in one of the challenges.
So for this one, the targeted audience, most of the DBs already they will spend day-to-day activity doing this one. But I would like most of the application developers also they will write queries, they will spend the time. So at least a basic analysis should be done by them. So whenever they say that okay, business got impacted, at least there's some analysis should be starting from their side also, like what exactly is making all these type of queries are taking time. So this is the targeted audience, actually cloud engineer, database enthusiasts, then technical solution. Right. Okay, so let's see some of the challenges. So one of the challenges, scary plans and statistic out of way. So most of the time we see that okay, I have like 200 lines of explain and analyze plan, right? And it is going to take a lot of time to understand where exactly is the issue, right? So most of the times we will see that you get a call by saying that okay, my business is running slow and impacting, and most of the because of 1 or 2 queries, right? Complete business is going down or affecting. So in that case, so what will be the symptoms actually, right? So symptoms are like slow running queries, and then you will sometimes you will observe that there are more sequential scans happening or stale data. So these are common symptoms what we see, but most common symptom is what we will say is whenever you try to debug the query, first of all you need to find it out what exactly or which query is taking time. So how you will find it out? You have multiple catalog tables which will tell you okay, this query is running from from long time on the database, and which is almost acquiring your CPU or memory, and which is impacting all other queries on the database, right? So here first of all, when I talk about the explain plans, so if you have like a big explain plan, and how you will understand that, first you need to understand like most of you know that this is a cost based optimizer, PostgreSQL. So you need to understand like okay, whatever the explain plan, the plan whatever generated, whether it is efficient and it's showing me as a good plan or not. Okay, if it is not showing a good, then what I need to check? I need to check whether there are frequent DMLs happening on the table, whatever there in that query, and whether the stats are getting properly updated or not, right? That is the important thing, because most frequently we will see that if stats are outdated, then query will start giving you, optimizer will generate a bad plans, and because of that, you will see that query is getting affected, right? Or you need to see there is a right index, and which was the data was less in that table, and there is a right index which was like getting picked by the queries till yesterday, but today the data has been grown, and now whatever the index, right? It is there on the table. It is not actually working as it was working yesterday. So all this you need to do the analysis. So for each and every category, for each and every challenge, we have like 3 slides. Uh, one is like symptoms, then analysis, and then what should be our resolution, right? So this is one of the thing like analysis how we will do. And whenever we see that stats are getting stale, in the sense frequent DMLs, right? Or there are the DML, because of the DMLs your stats are getting outdated. Because of that you will see that a planner will generate the like over or underestimated plans. In the sense it will try to stop using, or I mean giving an option of picking the index, right? Because you are not performing proper analyze on the table, or if there are proper I mean very frequent update and deletes, you are not performing vacuum analyze. So could be one of the reason, and because of that it is purely going into the sequential scans, right? Or the query, I mean query might be itself wrong till yesterday because there was less data and you might have not observed that, okay, the whatever the query you have written, that might have some issues. But till yesterday the data was small, it was working fine, but now today data is grown, so might be some join condition, hash condition, or I need to rewrite the query. So that also you need to think of, right? So most common reasons we see large write operations as like data is growing, or there are issues with your auto vacuum. It means that you have not tuned properly. So there could be a possibility that you need to see whether I can tune the parameters not only on the database, but whether I can check the table, and if it is frequently hit by the DMLs, then we can also look into the table level parameter setting. Okay, so some of the resolution, like if you see, this is the scary plan actually. So there are too many reds and oranges. Uh, so, like if you start reading this, right, it is going to take a lot of time. So that is like war between me and time to read this one, to understand and give the fix, right? So this was a simple case where we saw that, okay, it was literally taking time, and that is because of no frequent analyze was performed on the table. And then after vacuum analyze we refresh the plan, and query planner started taking proper indexes and all. So if you see that right side, right, so here after vacuum everything was clean, and then we saw that, okay, it started picking up the indexes properly.
Okay. Okay, so now let's take a second example or second challenge, which is ineffective vacuum process. So vacuum is a common process or a daemon which is specific to not only to Postgres but in different names and formats. It is available in all databases. What exactly is the purpose of this? So first main point is MVCC architecture of Postgres. What happens in MVCC architecture of Postgres? If someone is deleting or updating any row, it will not get deleted from the file, or from hard delete. It will be a soft delete. It is lying over there, but it is not visible to queries, right? And because of that, what happens is if vacuum processes are not running, which is not clearing these dead tuples or dead rows, then it might bloat the table. Maybe it is showing you 100 rows, but it might be behind the scene maybe 10,000 or 500,000 rows are there behind the scene. So that's why it is very important that these bloating gets cleared, right? And when these problem happens, or the problem is because of vacuum, you will see some of these symptoms. One is obviously slow running queries. You will quite often see like slow running queries because that is the first line of first issue that anybody sees. Like no, today I am seeing like no, database is not running slow. Maybe because of gut feeling. Maybe because of they have actually seen some queries which used to take milliseconds is now running like for minute or two. And that's why one of the common reason is to identify there is something wrong in the database is slow running queries. But just to identify whether it's vacuum or narrow down to vacuum, it could be blotted rows, there are multiple queries available, and you can see how many tables or which tables have more bloating or more dead tuples are available. And then it could be as worse as large tables which has large write activities happening. The system can also become unresponsive. Like I'm running any query and it is taking time, it is not giving me a response, right? And then the fourth one, which is little not so common, will not happen that frequently, but that will also happen if high write activities are happening. That is transaction wraparound, when it has exhausted all its transaction ID, because in Postgres you have to do about 32 transaction IDs to run the transaction, and once it is exhausted it will go into read only mode. So that is again a challenge which we have to, at any cost in production, have to make sure that does not happen. Go to next slide. Okay. So how what are the things that you will check, or what are the things that you will look into to identify this is the point here is because of vacuum. One is long running transactions. You see a lot of transactions are running, multiple updates, large updates are running for minutes, and those activities are happening. In some tables you might see, like if you look at the last screenshot, that auto vacuum is deliberately turned off. That means auto vacuum is not running on that particular table. So the cleanup is not happening automatically. The table itself is bloated, maybe because of multiple reasons. So that's why I have highlighted that even auto vacuum takes a log, which is shared update exclusive log. Is some activity which is taking this particular log or above that, then even vacuum is not able to remove those dead tuples or bloating. And that's why it is important, those kind of activities which takes log higher than that should be reduced, right? And that is why you have to tune your queries, you have to run manual auto vacuums, manual vacuums as well. So, and there are two more examples where you might have vacuum related problems, which we have mentioned. One is replication slots abundant, and then prepared statements which is there but it is not getting completed or committed. So those are also another challenges where the vacuum process might be wrong. Okay. So these are some of the things that I wanted to highlight, that during the vacuum process when it is running, still it is not able to remove those dead tuples because of the log which is taken by different processes. PG start user table is common, where you can check how many dead tuples are there, right? And vacuum off is there, and then there is a custom setting. Means user might have identified, like I need to be a little aggressive on auto vacuum setting, so you can do that at table level. Going to resolution. Now there are two ways to look at solving these issues. One is short term and one is long term. Long term will definitely need more analysis and deep dive in your design, in your understanding why it is having bloat, or why do we really need an aggressive auto vacuum or not. In short term, if you have identified, okay, maybe some reporting activity is going on, we can wait on that. You can kill those sessions which is holding those logs, and let the production server move ahead. So yeah, you can see, like there are how can you kill that process? You terminate backend and cancel backend. There are two ways to do. Most of the time you will see like there is no option but to terminate, but there is a graceful mechanism also where cancel request can also be raised, but it will take some time. That forceful cancels the session connection as well, so it might require rebooting your application or something like that. And then these are two for prepared statement and replication sort, and these are buffer hits, just to show like why buffer hits are high, because there are dead tuples, and that's why planner is doing a lot of disk IO or disk read activity, and that's why buffer reads are high. Okay, so that's take care of vacuum issues.
Okay. So one of the topics, like most of you, if you have attended yesterday's session, I was discussing about the idle connections, right? So this is one of the major thing what we see when you are new to the PostgreSQL, and if you are not using proper, poolers and all, right? So then you will see some of the issues, because see, whenever you are designing the application and you know that okay, it is by surely that my database is going to hit with this many concurrent connections and all. So sometimes we will miss somewhere that okay, I need to add something between my database and the application so that there should not be a connection left on my database, right? So most of the times I see whenever we work with the customers, right? So they start telling that okay, all the connection got occupied and we are getting some of the errors like no connection left on the device, right? I'll tell you, like I was working with one of the telecom company, and we have upgraded the database from I think 9.2 to 9.6. Okay, upgrade was successful, everything was successful, and after 2 days they called me by saying that now our like primary is down because of that error. What if you want to show that error? You want to show that error? So because of this error, like too many connections, it completely went down. So then I realized that okay, then I asked them whether are you using any poolers to between your database and your application so that the connection should properly ended up. They said no, and the value of max connection what we said was 3000. Okay, and when we started doing the analysis, then we realized that almost they were hitting regularly, like very frequently, or active connections, I must say. It was around 300 to 400, but 3000 connections were eaten up almost. So that was surprising. So yeah, can you go back? Go back. Okay, so one of the thing is like idle connections. So what will be the symptoms? Okay, so now I have a database and I'm setting the value to high, but still, okay, let it be there are idle connections. But what is the impact of that? First, we need to understand. Okay, so whenever there are idle connections in your database, it means it is doing some work, right? And it is eating up the memory as well as the CPU because this is a process based. Whenever a database whenever a connection is initiated, a lightweight lock will be acquired on the OS level from the OS level, and it will release a little bit of amount of memory as well as CPU to do its work, right? So okay, so how you will do the analysis? Basically, like you can do it like you using if you have any monitoring tool, you can do that by comparing like PGStat activity where state equal to idle. I'm not talking about idle in connections. I'm talking only about the idle connections, okay, which are not doing anything, but a connection is left like that in your database. Okay, so this is the use case, test what we did. Okay, so if you see the max connection was set to 100, and then in this diagram, like sorry, in this snapshot, if you see, like almost there are idle connections. This is a stop result, and each, so if you see this column, right? So here you are seeing like almost 2%, 2 or 3, this is in kbs actually. Okay, so memory is occupied and they are not doing anything, it's just left out like that, and it's using resources of your database or your server, right? So if I calculate that one, 40 plus idle connection, it means, yeah, 40 plus idle connection memory usage. If you calculate, it's almost 0.3 kb into 40, let's 12 kb, right? So this was my local database. It means in my laptop. But if you go with the production and all, you will see this will go into MBs also. Okay, so this is the analysis what you have to do, and you have to tell your customers. And similarly, we have performed one of the TPS result when there were idle connections and the resource were occupied. So if you see the TPS, it was like 856, and then we killed the connections, and then if you see, at least it is increased by 25 or 30 count, right? Next. Okay. So now what is the resolution, right? So one is, if you are not using any of the pooler or anything in between, so try to, as soon as you complete your uh, uh, like activity, application should properly commit and close its connection so that the connection will be available for the next transaction or next session. So that is one thing. That is, like you can see like as a short term result, and then uh, closing the connection, running connections which are not there. And second is also short term is, if you are identifying that okay, I cannot do the changes, now itself, then what you can do is you can write some queries on the database level as a script or schedulers, and you can kill whatever the connections are in idle. Okay. Next, what you can do, so most of the time, whenever we work with the customers, we will always recommend to have a pooler, so that what pooler will do, it will occupy some of the connections, and always it will make sure if there is a pooler, from that pooler, it will automatically, it will release the connections to connect to your databases, right? And once the work is done, automatically it will kill it, or because of timeout it will kill it, or it will reuse that connection for the next activities. So likewise, on the database side, if you want to go with the poolers, we have like a PG bouncer or PG pool.
Okay, so the next challenge is multi-transaction. So so we'll quickly look like how Postgres performs a transaction. Let's say there is a row which is getting updated through a process. Postgres will allocate a transaction ID or XID to that, right? And it will do its transaction, and after that it will release that after the commit or rollback the transaction ID to the pool again. But there could be case when same row is getting updated from multiple other transactions, right? Let's say 100 and 200 or 1000. So in that case, there is a secondary data type, structure which is created in Postgres called multi-transaction. So what it does is it allocates a multi-transaction ID to that particular row and create a separate list of transaction which is holding that log. So rather than having multiple IDs in a queue, or because whenever there is a transaction ID, xmin is updated, which has a limited limited size for in the page header. So that's why we cannot have multiple transaction IDs allocated to that. And that is why what Postgres identified as a solution is, we'll allocate one, we'll call it multi-transaction ID, and then we'll keep a separate list of those transaction ID, and accordingly as the updates or write activity will happen, we will consume or use that transaction ID accordingly. Now this common challenge we have seen is there are multiple skills in which this can be seen, but commonly occurrence is foreign keys, where one table has multiple references for the same row ID, right? And this can occur commonly. Sometimes it is little hard to identify. So recently in one of the Postgres version, they added lightweight log with description of multi-exact. I will go to that next step. So symptoms could be slow running queries. Applications start facing timeout because the transaction ID is not getting completed. So timeouts are happening. But in that case, what you will also see is that CPU loads are not increasing. Things looks healthy in those terms, like cache hit are good, but the system is still unresponsive and not giving you the right performance or right throughput. So based on these analysis or factors, you can identify that could be a reason of multi-exact issue. Look at the PG log table and PG stat activity table and look for these types of lightweight logs, multi-exact member buffer or multi-exact offset buffer. This could be a reason, or this could narrow down. Okay, this problem could be because of this multi-transaction activity. And the common factors is foreign keys. Select for share has been commonly used. Either maybe somebody is manually doing, or your application might be using these kind of selects. And then there are complex procedures or procedures being used which has sub transactions or explicit save point where it is creating partial commits and partial rollbacks. And then ORMs also have these mechanisms to handle transaction in their own way, and they create these kind of lock chains and create multi-transaction issues. So recently in version 13, PG stat SLRU stats view was introduced to gather some details on multi-transaction activity. Okay. So here, what you can do when these kind of issues happen? Obviously, the common is either you reduce your long-running transactions, but there is one more parameter which is introduced called multi-exact freeze max. and this is this has a default value of 4 million. If you see auto vacuum freeze without multi-exact is defaulted to 200 million, but it is 400 million. So you can reduce that so that it becomes a little more aggressive and try to reduce these multi-transaction activities automatically much before it creates problem to your production server. And obviously you keep an eye on other matrices like lock weights and idle transaction, etc., to narrow down this issue. So that's all from multi-exact, how to resolve that.
So next one is memory utilization. So how many of you, on the daily basis see that, okay, my memory is going, beyond, like only there are 5 to 6 connections on my database, and you will see that, okay, it is like completely memory has been eaten up by those queries itself, right? So it's a regular and common issue. So basically, most of the times what we see is there could be possibility that, so I mean, okay, I'll go with the symptoms first. So what will be the symptoms? Like slow running queries, right? It was fast earlier, but now it is slow running. Why? Because you might be seeing that, okay, the complete memory is getting dropped and it is being eaten up by these 5 to 6 connections, whatever actively running on the database. So what you will do? You will try to start, investigating what exactly is happening on my database. Okay, so analysis, what exactly is happening? First, you will try to identify, okay, now I have 5 active running queries, and out of which I'll try to find that, okay, which query is taking time, right? So not all 5 active connections are consuming memory. Out of 5, there could be a possibility that only one is doing all the, consumption of your memory, right? So first you need to find out uh, which connection or which query is taking time. Then you need to review like what whenever like this query is running, what exactly is happening at the background. So here one of the analysis. So this was the case where we have seen rapidly data was growing into one of the table, and there was a index for like two on the 2 to 3 columns, and then what we have seen that initially it was working well when I've seen that, okay, the data was small, it was working well, and sequential scan was also, it was doing a sequential scan, but the performance was good because of less values whatever I used to see in the table. But when data grown, the complex, the plan became like complex for me, and the sequential scan has like caused headache for me because it was doing more external merge. External disk swaps. Okay, it was doing a sorting operation, moving all the data because fall short of my work map. So we have tuned the work map, but still it was not working. And then what we thought, okay, let's create one more index which is actually use that query should use the index. Then we have created the index, and we have seen that, okay, it started picking up the index only scans. If you see the plans, right, same query, we did just one change by creating index. So if you see, instead of going for the sequential scan, it started picking up a right index, and it was like the query started giving us the performance. And if you see this one, right, so here I'm just showing OS level stats. This is freeable memory, and if you see, there is almost 100 MB of drop. So when we did this change, so this is like local database thing, but if you do this kind of analysis on your production, you will definitely see a lot of difference. A small change can almost make a very good give a very good performance to your queries. Okay, so always I don't recommend to go and change the parameter. Yesterday also I told you the same thing. Okay, so resolution, yeah. So stop the run, like the query whichever taking more memory. If it is possible to stop that one, stop that query. Kill that, or you can cancel that query and then try to optimize that query, or try to add indexes, right? And make that query or change that query. Like most of the times we will see that join conditions and all, if you are tuning it, definitely it will work. Yeah. And Then the last option, if nothing is working, you have to definitely do a vertical scaling, that is upgrading your hardware, which is the last and long-term recommendation.
Cool. Okay, so having said all these challenges, one of the common challenges still remains the same is lock contention. Because if something has taken the lock and not able to update, let's say updates are running or deletes are running, and it is creating, lock contention in your server. So it is making your read might not get that much affected, but your write activities are getting affected. In OLTP operations, it is very likely, like you might be doing a lot of updates. If it is taking time, definitely your server is not performing well. Now you might have also seen, like multiple times we have put one symptom, slow running queries, slow running queries. The reason behind that is because it's a common first indicator, like something has gone wrong. And if you look at database as a application altogether, so database is more IO bound activity rather than a computational problem, because you are trying to update the data more, insert the data, residing the data in the disk, in the cache, in buffers, and all those kind of activity. But at the same time, database has also to maintain its OLTP feature, which is ACID properties, and that can only be protected by having right level of locks, so that the things are isolated in right fashion, so that data integrity does not get compromised. Right. So, what type of transaction are included in lock? Tables, rows, indexes, and all those kind of stuff might be taking exclusive lock and avoiding all other transactions to get do not get to that point, so that they can perform their activities. So you will see like high occurrences of high weight events, right? And then you might also see log wait timeouts are happening, because some transaction is running longer than required, and that's why it is timing out. So analysis is look at the active number of transaction. If it is very high than the normal, then it's a high indicator log contentions are causing issues. Then look at the log trees. Means they're cascading. One activity is restricting other activities. I will show you one screenshot. So this is one of the screenshot where we are trying to show this particular query is getting affected because of these two other PIDs or process IDs, because they are also running some update which has already taken the logs. So PG logs, PG stat activities are tables which you can refer to gather all these kind of details. You can see over here. So exclusive logs, multiple exclusive logs are there being taken by different processes. Log counts are there, how many logs are currently being utilized. You see average wait time has increased. 8 seconds is way much more than for a production server which should be running in the millisecond range, right? And then you look at the active connections, that those active connections, some are in idling transaction. Means there is a transaction, but it is neither completed in terms of rollback or commit, and that's why it is creating a challenge for you, right? Go to the next slide. Okay, so how will you resolve that? Obviously, if you the things like we can kill some of those queries to make it run and to reduce this blocking, then that can be a short-term issues. But obviously, long-term you have to look at some of the common things which get overlooked. Is if the auto commit mode is not on, because Postgres runs in auto commit on mode. Whether if we take example of Oracle, it is more performant in auto commit off mode as well. And then query optimization. Obviously, it could be we have taken simple examples of update, but there could be complex updates are running. There are transaction boundaries between application which is holding a lock across the boundaries and creating complex situation of blocking. So that can also be that should also be taken in terms of query optimization. And obviously take the updates, vacuum, etc. in place, so that things are running. And another complex challenges or indicator of that things at the lock level are not working that fine is you will start seeing lot of deadlock events happening in your Postgres log. So that is also a thing one should be looking at your Postgres logs, that how frequently or in a common scenario, in general scenario, how many deadlocks do you really face? If you are today facing more deadlocks, there is a good indicator that something is gone wrong. Okay, so go to the next. Can we have a demo? I think time is already over, but we wanted to cover that. So some of these extra.
Some of the again common challenges we see. I'll not go in detail, but like in case like next time I'll try to cover these also. So these are the common scenarios we see. 100% CPU. Most of the time we see that queries will consume like 100% CPU and then impacting too many. So most of common challenge, before the native partitioning was this one because of like if you are trying to partition the table even with the triggers and check constraints, then definitely though it is trigger based partitioning part, but still you used to see other challenges, like if you are trying to update the main table because of the triggers and like it used to acquire check constraint, it used to acquire the lock on all the partitions, right? And some of the challenges have sorted because of native partitioning, but if you have a big tables, always it is recommended to go and do the partitioning if possible. Yeah. Then nested transaction and save points, and then replication lag issues, and then suboptimal parameter configuration. It means like whenever you start working on PostgreSQL upfront, you cannot. You should not do changes to the parameters. First, you need to analyze your workload, and then only always try to tune your parameters. Right? That is like recommended. So some of the important links we will share this PPTs with the organization. Like they will upload these PPTs. Yeah. Any questions or anything? If you want to give the feedback.
Thank you. Yes, sir.
Okay, great. So see, like as I mentioned, this is a process based, right? Whenever you are running query and I'm sorry. So whenever you do top command, or if you are using stop that kind of tools, right? Definitely you will have one row. There will be a one column by called as memory. So that will tell you like how much this process is consuming the memory, and then you can identify the PID of uh, on the OS, and the PID in your pgstart activity will be same. So using that one, you can figure it out which query is taking more time. But if you are going with the managed service and all, otherwise if you are using a Datadog or Neuralink, even that will give you a feature of tracking out like how you can which query is taking more memory. Huh?
Okay, thank you. And you were mentioning about idle sessions being terminated using a script, right? I just wanted to add that PG14 onwards, we have a idle session timeout, which Postgres itself takes care of cleaning up those sessions.
Thanks, everyone.